Now let me give you some help on homework number 4, and we're now down to problem 6 and 7, and this involves section 4.2 on steady state currents. What that means is that if we go back to this plot that we've dealt with before in a previous video, steady state means wait long enough so that this is pretty much steady, so it's pretty much a straight line. If you're charging a capacitor, or if you're discharging a capacitor, wait long enough so that it's completely discharged. So wait until it's straight line. Theoretically you can never get there, but experimentally you can say, well, we've gone long enough. So for example, on this problem here, and by the way, I'm using the 4th edition for this video of the textbook, but the figures should be the same. Once you turn this circuit on, you have a power supply here, supplying a constant 100 volts, 2 amp current supply over here. So this is constant current supply, this is constant voltage supply. If you wait long enough, what will happen is this capacitor will get completely charged, and that's what it says up here. Wait until you reach that point where you've done good enough, 99% charged, and it's really not going to conduct electricity, ever. But also this wire is not going to have very much current at all. We can say that in the steady state situation, this one has 0 current, because once you get it completely charged, then there's no reason for current to flow. So that would make I1 equal to 0. That means that the only current that could be flowing in the circuit is the 2 amps that goes through both the resistor, the other resistor, and the inductor. So an inductor does conduct electricity, but capacitors don't. There's a gap in between it, an insulating material called a dielectric, so you don't get any conduction through there, and you don't get any current flow up to it if you're in the steady state. Alright, on 422, let's analyze this one. You close the switch and you wait a long time and see what happens to the currents, I1, I2, I3, and I4. And the way that you treat it is that if it's a capacitor, treat it as an open circuit if you wait a long time. If it's an inductor, just treat it like a wire. It can conduct electricity. So that means that if you have 100 volts across this, then it looks like the current through this leg right here would be 100 volts over 10 kilo ohms, because you're just replacing that with a wire. And I guess that makes it 0.1 amps. Now over here, this acts like an insulator. So now there's no current going through there. So this one right here was 0.1 amps. This one's going to be 0 amps. Come back over here, another 0.1 amp, because it's basically just 100 volts across here. And there's your resistance. So V divided by R gives you I. And since this is 0.1 and that's 0.1, that makes this one 0.2. Sum of the currents coming into, the summation of the currents coming into a junction is equal to the sum of the currents leaving the junctions.